All right. So today we're going to be going through chapters 3 and 4 of Isaac Newton, and then obviously on into 5 and 6 as well. The plague years. In 1665, the University of Cambridge was shut down due to the plague, and Newton was forced to go back home to Lincolnshire. So similar to kind of what we experienced with the coronavirus back in the spring, they weren't sure where this disease was coming from, and so to keep everyone safe, they had to shut down, and everyone was sent home. Now, typically, people would be kind of bummed to spend a year and a half at home by themselves, but Isaac was kind of a loner, a little bit of an introvert, and so he didn't really mind being at home. He also recalls this as some of his most productive time. He said, "In those days, I was in my prime of age for invention," meaning thinking up new ideas. And many of the things that he thought up while at home would kind of inspire the rest of his career for the rest of his life. So he certainly did think up quite a few things. One of the things he thought up was the method of fluxions. Now, fluxion, it sounds similar to the word flex or flux, trying to be flexible, things like that. And it typically means continual change. This is basically a mathematical equation for things that are changing. More commonly, we call it calculus. Now, calculus is pretty complex, but I'm going to try and explain to you using this picture down here a little bit of what he was trying to figure out. So I have a picture down here of technically, it looks like a man, maybe a clown or something being shot through the air, but let's pretend it's a cannonball. I needed this picture because I need the different, like the picture of where he is at each point in the arc. But anyways, so let's pretend it's just a real cannonball. At this point in time, right as it's released from the cannon, the ball's moving very quickly, right? Now, the cannonball or the object does not continue straight up in this line forever and ever, right? Instead, the ball gets affected by gravity and air resistance, and as it's moving up, right about here, it slows down, okay? And even for a split second, it actually stops moving altogether. But just like you would experience on a roller coaster, as it comes over the top of the hill and begins to fall back down this way, it picks up speed and then moves very fast at the bottom of the arc. So calculus is a way to figure out what is the speed of that object at those exact moments. How do you find the speed or the change when the object is constantly moving? Okay, pretty complicated, but that's kind of the general idea. Another subject that always interested Isaac Newton was light. Now, according to Aristotle, white light was the basic form of light, and all other colors came from changing the white light. So, general white light, like the kind of light that comes from the sun, the kind of light that would be in your light bulbs in your house or in any building when the lights are turned on. Typically, it's just common white light. And Aristotle taught that all light pretty much starts at this form, and then we get all the other colors by changing that white light, okay? So Newton began to experiment with a prism. A prism is kind of like what you see in this picture here. It's a triangular prism shape. In his day, it was made out of glass. I have some that are made out of plastic or acrylic, but that shape, that clear object shape, when the light beam hits it, it causes the light to split into all the different colors. Okay. He knew that when you shine white light through a prism, it breaks into all the colors of the spectrum. Now, according to Aristotle, Isaac Newton was kind of experimenting with this. And if Aristotle's theory was correct, then if Isaac put another prism here, okay, then all of the light on this side of the prism should change even more, right? If the prism caused the white light to change, then the second prism should change it even more. But what he found was that instead of changing the white light, it actually combined all the prism back together into one single white light beam again. So what happened on this side was the exact same as what happened on this side. So what he determined was white light is not the basic form of light, but it's actually a combination of all the colors of the spectrum put together. And he was correct. So when the prism is acting on the white light, it's not changing it. It's just splitting it up to where you can see all the different colors. Through this experiment, he was able to explain how rainbows are made. So the rain droplets that are in the sky after a storm or a rainfall act as a prism. And when the light hits it just right, it can split the white light from the sun into the different colors of the spectrum, which is what allows us to see all those different colors of the rainbow. Chapter 4, Falling Apples. Newton's year and a half at home, when he was quarantined, basically, came to be known as his Annus Mirabilis, which is Latin for miraculous year. Now, discovering the true nature of light and inventing calculus was just the beginning. A lot of people think that this famous story of Isaac Newton's inspiration from the falling apple could have happened during these years at his home. Now, we do know that Isaac, he did say that a falling apple is what caused him to kind of think about, okay, well, what is this force pulling the apple, and eventually led to the discovery of gravity. But we're not sure if it happened during this year and a half or not. Now, we do know that obviously he was doing a lot of thinking and discovering during this time, and we also know that there were apple trees at his home in Woolsthorpe, but we don't have any proof that this actually happened during this time. And a lot of people say that the apple fell on his head, like what you're seeing in the cartoon there, but I don't know that we have any proof of that either. Now, Aristotle taught that objects have a built-in need to fall down. Okay. Obviously, he could observe that whenever we drop something on the earth, it always falls down, right? When it's just free falling, it never falls upward or to the right or to the left or anything different. It's always just falling down. So Aristotle said, okay, well, that means that all objects just have this built-in need to fall down. Newton, however, decided that this was silly and that there must be some force actually pulling things towards the earth. He also suggested that this force has no limits and also affected things outside the Earth as well, such as the moon and the planets. Now, this was brand new to people during his time. They thought that there were forces that worked here on Earth, and then there were other forces, different forces, out beyond the moon and on into space. But Newton suggested that, you know what, this force that kind of pulls everything down towards the surface of the Earth must affect space as well. No one really knows how far Newton got with these ideas during these years at home. It was a long time before he ever shared these years with anyone. For a couple reasons. Number one, he kind of just liked to keep his ideas to himself until he was absolutely sure they were perfectly correct. He did not like being corrected or told that he was wrong. So he basically would not give anyone the opportunity, because by the time he shared, he would make sure he was perfectly correct. And then he also seemed to just kind of like keeping his bold and exciting ideas all to himself. I don't know if he was just kind of selfish in that way, or if he was shy, or what the case was, but it seems like he kind of liked being the only one in the know, so to speak. Chapter 5, The Wonderful Telescope. When the plague ended in 1667, Newton finally went back to Cambridge. Isaac Barrow, one of his professors or friends there, probably professor, I think. Anyway, he was the first ever professor of mathematics at Cambridge, encouraged him to share the discoveries he had made. Isaac kind of came back and showed him, look what I figured out, while we were on quarantine. And Barrow was like, listen, these are pretty incredible. You need to share these with everyone. So Newton reluctantly, meaning he wasn't super excited about it, but he finally allowed him, let Barrow show his method of fluxions, or what eventually became calculus, theory to a small number of people, but he absolutely refused to let it be published. When Barrow left Cambridge, he thought so highly of Newton. I think that's Barrow in the picture. I don't think it's Newton, but it might be. Anyway, he thought so highly of Newton that he appointed him as his replacement professor. Basically said, hey, I'm leaving, but I know a guy that can take my job. Now, this was exactly the kind of life Isaac Newton wanted. He could get paid to teach and study and discover. That was his whole deal. Now, he wasn't a great teacher. He was actually very boring, and not many people came to hear his lectures. However, he didn't really care. He often would just walk around campus in clothes that didn't fit him correctly, uncombed hair, probably looking kind of like a hobo or a bum, but that was just kind of the way he was. He didn't really care what anybody else thought. He was only there to discover and learn. Now, Newton would often get so busy thinking that he would forget whether or not he had eaten. The rumor around campus was that his cat got fat eating all the food that Newton forgot to eat. He would get so lost in his studies and what he was working on that he would oftentimes forget to eat his food. And sometimes he would fall asleep just right there at the table or right there at the desk. He only slept only a few hours at night and often not even in his bed. So he wasn't great at taking care of himself. Newton wanted to learn more about the planets and how they move. To do this, he decided he would need to improve the telescope. The telescopes of the time would use a lens that would kind of act like a prism and break apart the light, which would produce somewhat fuzzy images. It wasn't super clear. So Isaac Newton decided, you know what? I read about one time how you could use a mirror to reflect the light rays, and it wouldn't cause the image to be quite so blurry. It would be a little more clear. So he created a telescope that used a reflecting mirror to create a smaller telescope that produced a much clearer image. Chapter 6, Fighting About Light. Now, Newton's new telescope really impressed this certain club in London called the Royal Society. This was a group of men that met scientists, I guess, that met every week to watch experiments and talk about science. That was kind of their whole purpose, was to get together, discuss science, watch experiments, kind of see what's new in the world of science. They believed the best way for men to learn was to discuss and debate others' ideas. Their motto was nullius in verba, which is Latin for meaning don't take anyone's word for it. This time period is known as the Age of Enlightenment. In general, people of that day wanted to learn the kind of important knowledge that changes the way people think. They didn't want to just be told things and believe them. They wanted to actually learn and discover on their own. There was kind of this emphasis on learning and teaching and coming up with new knowledge. Newton is considered one of the Enlightenment's greatest figures, but unfortunately his personality did not fit the Enlightenment ideal very well. Right? The whole idea of the Enlightenment is you get together and share your discoveries, share your ideas, and make each other better by learning together, so to speak. But Isaac did not want advice from other people, and he didn't want to share his ideas. If they questioned him at all, he took that as basically them saying that he was incorrect or them saying he was dumb, and he would lose his temper. However, it was still flattering to have such an important group of scientists that were interested in his telescope. So he let Isaac Barrow display the telescope in London, where it was a huge hit, even with the king. So Newton donated one of his telescopes that he invented to the Royal Society, and in return, they made him a member of their club or their group. So he tried to fit in with his club. He tried to change his ways and began to share more of his experiments and studies. He sent them papers describing the work he had done with the prism 5 years earlier, and he even kind of bragged a little bit about it too. And over time, the members began to do what they did best, and they questioned some of his experiments. Wasn't necessarily saying he was wrong, but just asking some questions about what he did, how he could make it better maybe. But Isaac kind of was a little too sensitive and took this personally and thought they were attacking him. And so he fought back. He didn't accept criticism very well. He was especially aggravated with one member in particular, a man named Robert Hooke. He was a member of the Royal Society that was responsible for demonstrating the experiments at the Society's meetings. Now, he didn't believe that Newton's experiments really proved what Newton said they did. But disagreement of this kind is common among scientists. It's an important way to work out the problems with an idea and to make new discoveries. In science, you can't always demand that you are correct, right? It needs to be proven. And people questioning you actually makes your results stronger because you then have to defend it and make sure it's absolutely correct. And if you're wrong, typically they can help point it out. Unfortunately, though, both Hooke and Newton were sensitive and proud. They didn't discuss the ideas, they had fights. And after many arguments, they finally just became enemies for life. Unfortunately, Newton never learned to enjoy these give and take arguments with fellow scholars, and he went back to working alone, saying, "I desire to decline being involved in such troublesome and insignificant disputes." Basically, he kind of decided that teamwork wasn't really for him. He wasn't that great at working together, so he would just go back to working by himself. So this is where we'll pick up tomorrow, or I guess Monday in this case, and we'll get into chapter 7.